So we've finally arrived at the place where we can kind of list all this stuff out and really lay out a strategy for making one of these graphs. We are like extremely close to actually making a graph, which was in theory the whole point of this chapter. So let me lay everything out and then we'll do some examples in the next two videos. First things first, right? So this is for generic polynomial f of x. So step number one is identify our end behavior. Right, so that's based on those four different cases. It's based on the degree of the polynomial and the leading coefficient. So right, degree and leading coefficient. So we want to know, right, is it rise to the left, drop to the right? All those different scenarios, which one did we end up with? So working away from the outside in. So that's going to tell us what's happening farther out to the right and to the left. Step number two, find all the x-intercepts. Maybe there's only one. Maybe there's one x-intercept. And use our multiplicity to determine if it's a touch point or cross point. So we want to find all the x-intercepts and we need to know if it's a touch or a cross. What you're going to see is that when we do that, that gives us a pretty good sense of the overall shape of the graph. Those two things honestly give us a lot of information. That might not seem like tons and tons, but there's a certain kind of like logic to how all the things need to fit together. It's a little bit like a puzzle, right? All the pieces sort of fit together kind of in only one way. And so depending on this end behavior and the intercepts and whether they're cross points or touch points really is going to tell us a lot. So these last couple steps are also important, but they're not going to have quite as big of an impact. The third thing is find the y-intercept. Right? So again, that's where you're finding sort of f of 0 equals our y-intercept. So that's just a matter of subbing a value into the function and then just finding what that value is, right? Find the y-coordinate. Could be something kind of big, like we saw that negative 192 was pretty big, but could also be something a little more reasonable, like 6 or negative 2 or 5. We're going to get a big variety of things with our graphs. Step number 4 is test for symmetry. Right, even or odd. In theory, you could graph without knowing the symmetry, but if you do know that your graph is symmetric, it's going to help everything come together. It's another piece of information, and in theory, right, it's another puzzle piece that should sort of confirm some of the other things that you're finding. If you, for example, find that your function is symmetric to the y-axis, but you're not necessarily getting like paired x-intercepts, negative and positive, well, that could be an issue, and either you missed an intercept or maybe your symmetry test was off, right? You kind of want all these things to be consistent and fit together. Step 5 is we're going to use turning points, which we're going to talk about in a second because we haven't talked about it yet, so this is new. To double check your final sketch. What the heck is the turning point? I thought you said we were done. We are mostly done. So turning point these are essentially our relative maxes and mins. Actually, max min points. So this is going to be where our function shifts from, so increasing to decreasing, or from decreasing to increasing. So literally, right, turns in the graph. It's sort of your peaks and valleys, right? It's your relative maximums and minimums. We sort of said these graphs are going to look kind of roller coaster shaped. They're obviously going to have a lot of ups and downs. The idea is to sort of connect all this stuff with a nice, like, smooth curve, not to be drawing like straight lines necessarily. And what's going to happen is, as far as turning points go, is your like max amount of turning points so is going to be the degree of your polynomial minus 1. So when you make your sketch, right, the idea is not to just sort of willy-nilly be sort of doing a bunch of up-down kind of stuff. You want to be really structured about it and purposeful about it, and you kind of have this one last final check as far as how many different potential sort of shifts from an increase to a decrease, how many of these like peak points could you have? And the answer is you're only going to have as many as your degree minus 1. So if you're up to like a degree 4 polynomial, you could have as many as 4 x-intercepts, but you're only going to have at most 3 different turning points. If I just sort of draw a random curve down here, for instance, I keep drawing something that looks kind of like this, so why not? So what's on here? We have like 3 x-intercepts, and then our turning points, right, when we're shifting from one to the other, would be here and here. So that's 2 turning points. That seems totally fine. 3 x-intercepts means we're kind of degree 3 or above, right? 3 or higher. 2 turning points would kind of fit with that. The degree would need to be 3 or above, right? So if we've got 2 turning points, the degree has to be at least 1 bigger than that, right? Because this is the sort of relationship. So these things fit together pretty well, right? The 3 intercepts and then the 2 turning points. This works. This would be, right, sort of rises to the right, drops to the left. So maybe this is a degree 3 polynomial. That fits too, right? This sort of end behavior, right? Up and to the right, down and to the left. Degree 3, you would think, right, you'd need to have an odd degree there on the end, so that kind of fits, and it looks like if it's down to the left, up and to the right, you'd have some sort of positive leading coefficient on that leading term. So to a certain extent, all this stuff has to fit together, and it should sort of fit together nicely. This is a horrible image. Apologies for doing this. It should fit together nicely, and it should all go together. I don't know why I said it was horrible and then I did it again more clearly. I guess if you watched to the end of the video, that's your punishment. In any event, you should always watch the end of the videos. I promise not to do weird hand things in the future. In the next video, we're actually going to take all this stuff and we're going to make some graphs. So finally, we have enough tools. We've got all this stuff laid out. Let's actually do this and make a graph. Coming up next.